My name is Manuel, in case you haven't met me yet. I'm one of the TAs of this summer workshop, and in this lecture we are trying to set up your local development environment. We are talking about version control with Git, and we are trying to get you going with a remote workflow, which means you can, as Sarah said before, we have like remote machines with nice GPUs for you. And the goal of this session is that in the end, hopefully everyone can connect, you can navigate there and have an idea how to move your projects and data there. So this is going to be a very practical topic. So I think it makes most sense if we do it in an interactive way. I will sometimes switch between slides and like my VSCode interface I have open here. Feel free to join along if you have your local project open and want to follow step by step what I'm doing. And just raise your hand if anything is unclear. Like this is going to be pretty interactive. So we're going to start with setting up Python locally. And in this lecture, I'm going to show you how to set up VSCode, which is one particular IDE that we recommend because in our experience, it's pretty easy to use and pretty flexible. Of course, if you have another setup, I guess some of you already work with Python, you're comfortable with your own setup, feel free to use it. But this is the one we recommend and we could help you best with. Second part will be about version control, as I said, and the last part about the remote workflow. So what is an IDE? It stands for Integrated Development Environment, and it's basically one piece of software that should make your life easier when you're working with code. It's not just a code editor, but an actual IDE also has additional features like it interacts with your Python interpreter. You can use it to debug and to easily navigate in your code base. It has Git integrated, usually in a graphical interface, which makes it more convenient than working in your local terminal.
Just for some context, how many of you use RStudio regularly? Yeah, so, and RStudio is an IDE.
Yeah. Thanks. For Python, I think the most popular ones are VSCode. So VSCode is not specialized in Python, but very flexible, and you can easily set it up for Python. And the other one is PyCharm, also very popular. And I think there are many more. I don't have to mention here. Many of you might now ask, okay, what about Jupyter? Because Jupyter notebooks are in particularly popular in the scientific community. Also, I think people coming from R have a good time with it because it is kind of an interactive Python interpreter. Instead of running your script in Python file, you're using IPython notebooks, and you have like always you execute code in blocks, and you always get the direct output. While this is very useful in certain scenarios, for example, in teaching, when you're doing step-by-step tutorials, or also when you want to, I personally use it when I want to just explore my data, which is like not like a piece of code that's well processed, but I just want to look around, make some plots, visualize some figures. I really like to use it as well. However, I would not recommend to use it as your primary development tool where you like set up your whole Python project, because it has some disadvantages. One is version control does go very badly with IPython notebooks. This is because these files have like some kind of metadata in JavaScript, which like says if you have executed a certain block or not, and it's just awkward to do version control there. And also in your project here, you're probably gonna train models, which take several hours for like the training runs that take several hours. And you don't want to start that from a Jupyter notebook because then your interface needs to stay open, for example. You rather want to use Python there. So in summary, feel free to use it if you like it. However, for primary project development, would not necessarily recommend it.
Do you, if you include IPython notebooks in your project, do you ignore them typically entirely?
No, if you ignore them, you only have them locally, and I think you also wanna have them documented, have them saved in your GitHub or in your cloud. So I wouldn't. Yeah, it depends. Like if it's just a Scratch notebook that you don't want to keep, yeah, you can either git ignore. If you only do Scratch notebooks, yes. If your notebook actually has some kind of documentation purpose, I would definitely add it to the repository.
Maybe just wipe outputs or something before you commit it.
So
maybe just like wipe outputs before you commit it or something.
So if you're using Colab, there's an option that basically says do not save history, which then it'll just kind of keep the code but not the execution history. So that's a bit more convenient. Like I think Colab is slightly better integrated with GitHub than just a vanilla Jupyter notebook. But otherwise, I mean, it's fine. You're just saving off a bunch of this JavaScript stuff. It doesn't really kill you or anything. It's just, it's not easy to like necessarily sort of like start where you left off. It can get kind of weird.
Yeah, and it's mostly an issue if you have collaborators. Like if it's just you and you're just pushing updates to the notebook, that's fine. But if you have a collaborator and you're both editing it, it will just break it.
Yeah, and then sometimes it's unrecoverably broken, which is annoying.
All right. If you don't have VS Code installed yet and you want to follow this tutorial with VS Code, feel free to download it from this link and install it according to your operation system. And on another note, in general, many parts that we are covering now were already covered by Benjamin Kellenberger from last year's summer workshop, and there's a YouTube video listed. You can, like, if you afterwards you're struggling with something and you wanna follow it step by step again, feel free to check out this video. I think except of the Git part, it covers most of the things we're doing here now as well. Okay, so now the more interactive part starts. I have created like a new user on my machine. So this is plain Visual Studio Code, opened for the first time, nothing is set up. And kind of the first thing we want to do is check out the add-ons. Like a very important part is like the top left navigation here. And there is like an extensions tab. And this opens like a whole marketplace of extensions. And the most important one you need obviously is Python, which I'm installing right now. If you plan to use Jupyter notebooks within VS Code, you can also install Jupyter. I'm not gonna do that now. And one thing we also want to have, which gets important later, is like the remote SSH add-on. So you type in remote and it's literally the first thing that pops up. I install that as well.
Manuel, excuse me.
Yeah.
Can I use PyCharm or will it be more complicated?
A majority of the stuff will be on terminal commands, so you can execute them in your local terminal or in your PyCharm terminal. But one or two things are like I'm showing on the example of VS Code integrations. So
if you're already very familiar with PyCharm and you want to use PyCharm, you're welcome.
Yeah.
You can also treat this as an opportunity to learn to use VS Code, and then you can decide what to do later.
Okay, to start off with project, I actually need to open a folder. This is my user called cb4co. Didn't want to do that. Okay. So. Quickly close my VS Code, reopen it again, because I actually want to create a new folder. Sample project. And can you help me out? How do I make this as my project root now?
Installed Python so far. What else?
So he installed.
Oh, yeah, here, right. Awesome, thank you. Okay, so I went to a file tab, opened the folder, and this is like my project folder now. I can add a new file, let's say hello-world.py, add some Python code, hello world, and yeah, this is now the starting point of my project. So one of the first things we want to do is set up like an actual Python interpreter. We are recommending using conda, and in particular like mini conda, which is a lightweight form of it that doesn't come with a whole lot of pre-installed packages, but has the same functionalities. And the good thing about conda is that it has like a sorry,
are we gonna work off our own laptops or?
Yeah.
Okay, so we SSH into the GPU.
So we're gonna get to the SSH part later. So first part is about local setup, and many of these things we do here will be similar for the remote machine, but this is gonna be like the third part of this.
Oh, okay, so if we create a directory, so we will create, so the directory of our data will be on the remote computer or on our local machines.
Okay, I try to answer your question this way. Like there are different workflows you can follow. One you could do, and so we are covering two workflows here. One would be, okay, I set up my project locally, where I can execute it, but I don't have all the resources I have on my remote machine. Then I'm later going to use GitHub to clone it on the remote machine and check it out there. But there's also a possibility to use VSCode, for example, to just work on the remote machine. You still need to get it there and set it up, but you wouldn't need a local version of it.
Okay.
And I try to cover both variants.
Okay.
It has pros and cons. Like it might be less confusing if you only have one project that is remote, but on the other hand, you need like stable internet connection, which might be an issue here for some people. And yeah, some people also just like to have their files locally altogether. We're gonna start with installing a Python interpreter. So we are checking out this website, which is Miniconda, and depending on the operation system, we need to download a installation script. Since I'm using a Mac, I will copy the download link from here, or actually I'm gonna download it to my downloads folder, and then I'm going to execute this bash script to install Miniconda on my system. I'm going to do it in a terminal within VSCode. You can also like open up, in principle, like a terminal on your machine or in any other IDE. So we're doing it from here.
Maybe make your font bigger.
Yeah, this is very small. How do I do that? Does anyone know?
Zoom in on your whole screen.
Again?
Yeah, I think you
You
can.
can command the plus.
Yeah,
Yeah.
command
On
plus.
my Mac, but
Zoom in your whole screen.
Oh,
Yeah.
there we go.
Awesome.
Yeah.
Thank you.
The terminal.
that's my turn. How do you?
You go up here, like scroll and to the, what's it called, the navigation bar, and in the terminal tab, you can spawn a new terminal. Thank you.
Okay, I have it.
Okay, so I downloaded the file to the downloads folder. I'm going to execute it with a bash command, and I'm going to ignore this. This is something related to my machine, even though I have a 64-bit system. I don't know, I had this before as well. Then you need to read the end user license agreement, which we of course like accept. So we need to type yes. We need to specify the location. The default location is totally fine, which will be in your user's root directory.
Is it all right to install this through Homebrew on the Mac? Like Mini Conda is it has a brew formula, so it's Homebrew fine for installing that?
I guess so, yes.
Okay.
Yeah, just need to make sure that it's like, visible to your system as an installed interpreter. Like this prompt that is coming here, like, do you want to initialize it? This is very important, I think.
Oh.
Should appear as well when you install it via Homebrew.
No.
So, yeah, what this did is, since we installed it now, we can close and reopen our terminal. And then what you will see is that now we have this base prefix, which indicates that conda is recognized and properly installed. This actually is like the indicates in which conda environment we are. I will explain in a minute what a conda environment is.
Yeah.
But it's an indication that the installation worked properly. So when you're using Python, you usually want to install all your project dependencies, which are like third-party libraries, for one project specifically. If you install it to your system interpreter and have multiple projects, this will at one point cause issues because every project might have different dependencies. This could be versions of libraries, it could be the Python version itself. And
very specifically, because we're sharing nodes with everyone in your group, this becomes even more important because you'll all have root access on that node. It's very important that you don't install anything out of an environment to the machine because it will fuck up other people's projects. So don't mess with other people's projects and do everything in environments so that everything's contained and you're not changing things under the feet of other people. So this becomes much more important in shared systems.
Yeah, I think we've also set up specific users, which makes it a bit harder to mess with other people's projects, but still everyone has root access, so yeah.
I mean, you still, like, if they're like reinstalling CUDA or something, they could in fact fuck up other people's projects.
Don't do that.
Please.
Don't touch CUDA. Actually, that's just like a base rule. No one is allowed to touch CUDA on those machines.
Can you go back to that link really quick where the conda, where you went there?
This one?
Yeah.
Yeah, you can Google download mini conda. This is probably the first thing that will.
Okay.
And if there are a few more commands here, the second one is just if your system complains that this file is not executable, you need to set it to executable, like the permissions. And the last one just removes the downloader file. I skipped those. Okay, speaking of conda environments. So what we can run now here in terminal is like conda create, which is a command for creating a new environment. We give it a name, in my case, CV for E and for environment. And optionally, we can also specify the Python version we want to use. I think with Python 3.10, you're well off. If you know that you have dependencies that require a specific version, you can do it here. After creating the environment, we can, for example, check conda env list when we see that two conda environments exist, one is a base one and one is the one we just created, and we actually want to use the second one, so we call conda activate CP4E. Now you notice that the prefix here changes, which means that all Python related commands you're executing in command line, such as pip install or conda install, or also like Python in terms of executing another Python script, will use the Python interpreter in that environment, which is what we want to achieve. So if we call pip install pandas, for example, which is a popular library you might want to use, it will install it to the conda environment instead of the system-wide Python interpreters.
Do you have any guidelines about when to use pip and when to use conda install?
Good question. No, I don't have them. Does anyone know more about it? Like Python is the native Python installer, and when is it advantageous to use conda?
I think if it's on each school and if there's a conda version of it, then just do the conda version. Sometimes it's just no conda version.
Yeah.
I would say prefer to do the conda version.
That's generally my rule of thumb as well, mostly just because with all of these package management, so this is like one of the things that makes Python have a higher overhead for entry than R, is in R, all of this stuff is managed for you. You don't have to sort of decide like what and how to install these different components. Often, I actually try to figure out what all the packages are that I will want to use and explicitly install them all when I'm building the conda environment. So like if you have like a list of things you figure out you need to have installed, if you do all of that installation at once, then there's less likely to be versioning conflict. So when I actually generate my conda environment, I'll either build what's called a YAML file that defines all the different builds, and he'll probably get to that in a second, or I will kind of, yeah, like you can also just do it as a command line, like, you know, conda install, and then you put a bunch of like package names as you go. But some things are only installable via pip, in which case you kind of have to do them later.
So rule of thumb was use conda install if it's available.
Yeah, and also try to actually just set something up where you're conda installing almost everything when you generate the environment.
Okay.
Good, but that's just my own preference.
Okay.
You can make as many conda environments as you want.
So instead of pip install, you should have better than conda install, but the result will likely be kind of. Okay.
Also, like none of this stuff is set in stone. Like clearly, all of us have different kind of rules of thumb, and that's one of the things that makes it tricky. If you are already a really confident Python programmer and you already have a system that works for you, you're more than welcome to use it. We're just trying to somewhat standardize, because one of the things we did find last year is that it's easier to help people get unstuck if everyone's generally using the same set of rules to set up their system.
Typo here, gonna fix that.
Oh.
Okay. Okay, so we set up a conda environment. Something VSCode specific we probably want to do is we want to let VSCode know that for this project should use the this specific environment. So we are navigating to view, open the comment palette, and type in interpreter, and use select Python interpreter. Here, all Python interpreters that are available will be listed, which are like the system Python, the base conda, and the one we just created. So we select this, and the handy thing now is if we open a new terminal within VSCode, it will automatically run this command and switch to the environment. So we don't need to do that manually every time.
So I found if I made a different environment, it was quite difficult because I did like a first conda environment like this one, and that was like the default. So then it was quite difficult. I would have to like keep killing the terminal and opening it again to switch to a new conda environment. So are we expecting to only really be working within one?
But you can switch to another one.
No, you can. I just found that if I would sometimes have to kill the terminal and then switch, because it would for some reason automatically default to the first conda environment that I made, even if it wasn't activated.
But so if it defaults to the first one, then if you use the exact same, activate the different environment, it'll just switch to that one.
Yeah, I just found it was maybe my computer was just being slow, but I would have to kill the terminal over on the right. And then sometimes rerun the code. Maybe I set something to default by mistake.
But so, if it just, when you open your terminal, and at the beginning, it just says, my environment, whatever, like the first environment you made. Like the first thing that you would run
Just
would be,
deactivate it.
activate the environment you want to work in, and it'll just switch to that environment, and
So I
it
shouldn't
shouldn't
have to-
run anything.
I shouldn't have to deactivate the first one.
No. You're basically just saying, actually, I wanna go live in this other house, and
But it
you just walk over there.
it is possible to set a conda environment as a default.
Yeah.
Because I think that's what I did by mistake. Just always opens that one.
But then it's just a single line of code to switch, and you shouldn't
You shouldn't
run
have to kill the
anything.
terminal or like restart everything.
No.
So if I want to switch here to base, I just say conda activate base, and then I'm back to the base environment.
Like that fast, so it doesn't really matter if you have something set to default, you just wanna check that you're in the environment you wanna be in.
And also, just in the context of these shared nodes, like everybody who's sharing these nodes will have, if you like list the common environments, you're gonna see everybody else's common environment. And I'm assuming kind of will.
It depends, I think if everyone has their own
No.
user,
It'll be user specific.
it'll be user specific, yeah.
So make sure you install conda as a user and not as root, because then that's what you want to use. Then it should be pretty safe and isolated. Okay. Since we're already talking about conda environments, what Sarah just mentioned is you probably want to keep track and document kind of your dependencies and add them as explicit files to your project. And there are two options. One is like a plain requirements.txt, which could be I start a new file, call it requirements.txt, and just make a list of the dependencies I use. Right now I installed pandas, numpy, and matplotlib, pretty standard libraries. And you don't need to specify a version. You can look it up. You can be very strict and say I exactly need version 131, or I need something like greater of this version. Usually it's also sufficient if you just specify what you use, and your installer will figure out if that matches together. There is a similar thing for conda, which is an environment YAML. You can either create this manually and look up the syntax, or you let conda create one, which would be this command I listed here, like conda export file environment YAML. And this command. So on the env export, of course, okay. And this will create this file. And here you can also see all the dependencies we're using, but the disadvantage is it's all the sub-modules as well that are like dependencies from the packages we installed. So we installed like pandas, but pandas again has dependencies. And so these are all listed here, and these are all listed very explicitly with their respective version. So this is very strict. If you want that, you can use it. Otherwise, you can define it less strict by removing the version tags or by removing some of the dependencies. And the idea is that you have either one of these two files, either the requirements.txt or an environment YAML, and track it in the root of your folder. And yeah, just for other people and for yourself to, when you're first able to set it up faster on another machine, and secondly, it's like kind of a documentation to reproduce your experiments.
So would you use the short form just for readability purposes, or there's another reason why you might not want the full kind of documents from the YAML file?
You mean all dependencies in here?
Yeah.
I mean, it is stricter as it needs to be. And if someone, for example, has a slightly different Python version. Could also be like the major or minor version difference that might cause troubles. But yeah, readability is one point, and in some edge cases it might be too strict, so the package installer can like resolve it. So you might want to be less strict, but both should work.
So these files don't actually install the packages, they're just documenting which ones you, like, do you manually do uninstall?
If I have this file, if for example, you're sharing your project with me and you share this file with me, I can use this file in my conda create command, and instead of just like creating a plain environment which I then have to fill with packages, it will already install those. So if you have this file, it's perfect to use, and otherwise, yeah, first time you need to create it. All right.
I think there's another question.
Any questions?
Yeah, I've had a problem in the past where I like created an environment locally on my Mac and then I tried to export it to a Linux machine. And there were like some packages that I guess maybe were specific to Mac machines. So then when I tried to like recreate the environment on the Linux machine, it broke because it didn't want to install like some of those packages that were specific to Mac. Have you had like experience with that happen and how to fix it?
No, I didn't experience myself, but it might be a case of what we just discussed. Maybe, yeah. What I would try in that case, for example, is like, did you like use like these very strict, like did you export your environment?
Yeah.
And have then maybe I would try loosening the versions and just write something like this, where you just list up all your high level dependencies you have and let your Linux system in that case figure out how to resolve them.
Okay, thank you.
I mentioned one specific case where cross-platform can be hard is with CUDA. So using GPUs, sometimes there's versions of packages that are specific to your hardware. So that's a good place where you can listen to your requirements. Or you can look up, like, for instance, on PyTorch, there's a page that says like, if this is your hardware, this is the PyTorch version you want.
So in by loosening requirements, you could just remove the version number and the YAML file could still read that and install the appropriate one, or you just remove that package and install it independently.
If you remove the version number, it will probably try to install the default, but there is some like basically package handling behind the scenes that decide like if the two things will only communicate to each other if specific versions are used, then it'll kind of do all of that for you. And if you try to set an explicit version, then sometimes that becomes impossible, and you can end up with these like weird infinite loops where it's like this package requires that version, which requires this version, and then it like can't actually do it.
Okay.
And just one more thing, which is in case it wasn't clear, you can also use inequalities for your package requirements. So you can say a less than a version or greater than a version, not only like exactly a version.
Yeah, good point.
Okay, if there are no more questions, we would continue with a second part where we talk about version control.
How many of you so like let's say like red, yellow, green, like how are people feeling about IDEs? Yeah, thermometer. How are what's your vibes, guys, right now? How are we feeling? All right, cool. Don't worry if you're feeling like this. We will give you some more support in the sort of open work sessions and help you get that thermometer up. But just like, we know this is a lot of information. We don't want anyone to feel bad if they're kind of struggling. Yeah, cool.
Right. So let's talk about Git, kind of my favorite topic because I know a lot of people hate it. As well, but I actually love it. I think it's beautiful. It's elegant and as it's supposed to be. So what is Git? Git is the state of the art for version control in any kind of software and any kind of source code. And it is a distributed version control system, which means you don't need like a centralized like a cloud drive where you need to sync in real time if you do changes, but you can easily work offline and you can then sync once you're online again. It enables collaboration between different people and things like branching and merging, which means you create different versions of your code base and work on those. So Git as a command line tool is pre-installed on most Linux and Mac machines. I think for Windows, you might need to, if you're not using Windows subsystem for Linux, you might need to install, I think it's called Git Bash, which is Git for Windows. And a simple check if Git is installed and working is typing git ---- version in your terminal. So I'm gonna test that here. Git ---- version tells me, yep, it's here and it works. So some more about the concept. In Git, you can think of your current state of your code as like a list of changes. You start with some initial change where you create a file, and we call this commit. And on top of this state, on the top of first commit, there comes a second commit, which could be editing this file, adding another file, or deleting a file. And a commit only describes like the difference to the previous state, the delta. So it does not like save two full versions of the whole project, but if you only change like 2 lines in a certain file, it will like one commit contains that information. So it's a pretty efficient way of tracking your progress and changes. And yeah, if you want to get to your current state in your code, yeah, in this example, it would be like an aggregation of four commits, 4 changes. And before we were talking about, was mentioning branches. In some cases, it might be useful, especially if you collaborate with other people, that you say, okay, I want to take this version of the code and I want to spin off a copy where I do development on a specific topic, like a specific feature, without affecting the main version of the code, because I don't want to break things. And usually you branch off your feature branch, for example, you work there, and at some point when you're happy with it and you want to add that feature to the main version, yeah, you're merging it back. That being said, if you're mainly working alone in your code base, you're very well off with just using one branch, and yeah, except you want to do highly experimental stuff. But this is more of a collaborative feature. If you're using Git for the first time on your machine, you need to run these 2 lines where you're telling Git, you're giving Git some kind of meta information that it adds to the commits you're doing. So I'm going to run both of those on my machine. So running git config ---- global user.email. So this is, you're not registering anywhere here or anything. This is just adding meta information. It's just adding strings to your okay, with the .email, of course. And then I do the same with my name.
Sorry, just to check, should your email be the one that your GitHub account is registered with?
That doesn't really matter technically, but it might be useful, yeah.
Okay.
But it works otherwise as well. This is just this is independent from GitHub. Like we're still using Git just as a local version control, and it's really just some meta string that is added.
Okay.
But it's useful if it matches with your GitHub email, but not a requirement. All right. So speaking of GitHub, GitHub is a web-based platform that is based on Git projects that lets you track your projects, publish them, share them with others, collaborate with others. And even if you don't want to publish or share anything, it's very useful to use GitHub to have like backups of your projects, because you can keep them in private. You can just work on your own, but still you have a safe backup of your code in the cloud in case anything happens to your local machine. So there are also other tools that do the same. Maybe you've heard of them, like GitLab or Bitbucket. We recommend you to create a GitHub account for this summer workshop. It's for free. And we have created a namespace for where we like aggregate all the projects we're doing here. So if you haven't done yet, I would ask you to sign up and create a GitHub account, and just ask your instructor to add you to this CV for Ecology School namespace. And once you receive the invitation, you need to accept it. There is an email link, and if there is no email link, let me log in. So you can also open your settings. So this is a GitHub landing page. On the left, you can see all your repositories, which are like one repository is one project. And here you can see that I'm like part of two namespaces. One is my personal namespace, which is my CV for E-user, example user I created. And I can also switch to the CV for Ecology namespace. Which means, and if anyone creates and shares a project within here, all of us will be able to see it per default, right? Yeah.
And this is nice actually, because you'll find as you're working on things either within your subgroup or possibly as you're working on, even if you're discussing with someone else, you find out they're working on stuff. There's probably a lot of shared challenges here. So if someone builds like a really nice visualization of something interesting, then it's actually going to be, because all the code is kind of easily findable, not so hard for you to possibly pull that and adapt it for your project. So this is a nice way to make sure that everyone isn't necessarily always making everything from scratch. And it's nice because it gives a little bit of a record of what's developed during the workshop, and maybe you guys can even look back at last year's code and sort of start from that, from some of those projects. There's some template default things that Benjamin Kellenberger made. So depending on your project, as we kind of get into the nitty gritty of this, this does just give us like a shared resource of code to work from. If anyone has any reason that they need to keep their code private, your data is not public here, so no one will really be able to reproduce anything you're doing from the code. But if you have any specific reason that you really would like to keep your code private, we're happy to listen, and if it makes sense, that's fine. But otherwise, I think it is nice to keep it public.
Okay. So if you have a GitHub account and you're part of this namespace, that's already good. If you're working with GitHub for the first time, one thing you have to do is set up your a local SSH key and add it to your GitHub profile, because GitHub works best with SSH. So I'm going to do that now because I don't have one yet here, which is pretty simple. I'm opening my terminal again, and I just type SSH -keygen. By the way, if you're not sure if you already have a key, you might want to try navigating into your root.ssh folder, which I tried here with change directory, and there is no such a folder. So there is I haven't created a key yet. We will check in a bit what it looks like when you created one. So now I'm calling SSH -keygen. This is creating two files on your local machine. One is a public key and one a private key. The private one you're supposed to keep on your machine because that's like what is authenticating your notebook with any kind of remote service. The public key you can share either with GitHub, what we're doing in a minute, or put on any other remote machine. The default file is fine, and usually don't add a passphrase. If you want to be super secure, you can add one, but like the point is that you don't need a password if you create an SSH key. So if you want a double layer of security, you can add one. So we created that file. And if I now navigate to root.ssh and call ls for list directory, I see that these two files appeared, which is good. Might already very well be that you have them, so you can check. What we need to do now is display the public key. I do that with add idsr.pub, and I want to copy this whole thing, starting from sh minus rsa down to here. Copy it to my clipboard. And this is because I need to add it to my GitHub account. So I'm opening the settings, go to SSH and GPG keys. This is an old one. I don't need any more. Here I can say add new SSH key, just copy the whole thing here. And I'm good. So now that my user has an SSH key, it's way easier for me to interact with Git, because I don't need every time I'm trying to pull changes from a repository or push, and I don't need to type my username and password. Yeah.
Is this aspect covered in the video that was posted? The SSH thing?
No, the Git part is not there.
Okay.
But we are recording this session, and this will also be available like right after.
Yes.
We'll link it. So you'll also have this recording.
Okay.
And in doubt, just ask any of the instructors or TAs to help you.
Like later on, because this is too fast for me to follow.
Yeah. No, totally. And we understand it's a bit tricky with stuff like this because a lot of people have a lot of different backgrounds right now. So we're trying to strike a balance. If you're feeling it's too fast for you, like we promise, we have enough capacity in the instructor team to help you get up to speed during the independent work. Don't worry, you're gonna be okay.
Thank you.
Okay. So now that was there another question?
Oh, I just missed the part just before the SSH key gen. But it's easy to go over later, that's fine. I didn't quite see what you did.
Yeah, so it was very simple. I just called SSH minus keygen to create a key, accepted all the default paths, and then I navigated to .ssh in my root folder, and there are two files. And the public file is the one you want to share with GitHub. So you can either open that directory in your file explorer, or as I did, display the content of a file in my terminal.
And this isn't the SSH from that we were using that with the example. There was an example one in one of the assignments.
SSH. Can't remember.
When you should, it's like the same command, but
name it and then.
I don't know if the tutorial said like how you do the key generation.
Okay.
Yeah. You should just paste it in.
Here?
All right.
Do we only need to do this once ever or is it for each environment? Okay.
Just add.
Okay. Now we have our GitHub account set up, and we want to create a project. And we do that by navigating to our GitHub landing page. I will create one now in my own namespace because I don't want to pollute like the CD for Ecology one. So here's like this new button. Is it large enough? I guess so. Then you can decide on which namespace you want to create it. I use my user and say, for example, awesome example project. awesome example, whatever. And I set it on private because I don't want to share it with the whole internet. This is pretty important. Even if it's private, you can later share it with specific people and specific usernames. And also if you create it within the CD for ecology namespace, it's private, because public means like the whole internet. And I click on create repository, and this is like an empty repository now. And GitHub already tells us how to proceed. Like if you already have an existing folder or you want to create a new one, you just follow what is described here. In our case, we have a local folder, but no Git project yet. So we are following these commands. So I'm switching back to VSCode. I'm having my project with one file, and I only keep the requirements txt for now. And let me switch back to, I just make sure that my terminal is again like in my project root of example project. And then what I simply call is like git init. This initializes this project as a Git project. You can notice that certain things have changed. Like these files are green now, which means this is like a Git indication that they were changed and the changes are not tracked yet. And let's check the GitHub commands. Yeah, the next thing I want to do is like add certain files. Since I want to add like both files, I can just call it git add dot, which is like the whole directory. Another useful command is git status. Here you can see that both files are staged to be committed. So what does that mean? This means there are local changes, and I tell like Git which changes I want to aggregate in one commit. And now I need to create the commit, which I do in command line, which git commit -m, and I call it initial commit. And now you can see it was changed because it was tracked. And this is all local. Now I want to get it to GitHub. So let's go back to the instructions here. I can basically copy paste all of this. Like that's what I just did. Like init, git add some files, make initial commit, and now I execute these 3 lines. For the first time, I need to, since we're connecting with GitHub for the first time with our key, we need to type yes. And now we have pushed our commits to GitHub. If we go back here and refresh the page, we will see that these 2 files are here. So this was the low-level command line interface that works like everywhere. If you want to take a bit of a shortcut, you can use like the graphical visual code interface. So let's say we modify one file, like we add another print statement here, and we create another file like models.py. Then you can, if you on the left in VSCode, if you switch to this icon, which is like the source control icon for graphical Git interface, you can see that VSCode recognizes that these are changed. U stands for untracked in this case, M for modified, and I want to add both to my commit. This is the exact same thing I just did in command line, just more convenient. And up here I enter my commit message where I say create models file, and yeah. And here I can actually select commit and push, which is like shortcut for the 2 commands. And if I refresh my GitHub page, we'll see that it updated. So this was 2 times the very similar thing. And you can decide if you want to use the command line or the graphical interface. And also PyCharm has this, or any other kind of IDE you're using. Okay. So we went through this. We created a GitHub repository. Yeah, here I listed some of the commands. You can look them up. Not too important for now. One important thing is the gitignore file that was mentioned before. So there are certain things you want to track, which is source code, and there are certain things you don't want to track with Git, which is your data and any kind of temporary cache files that are potentially generated by your system. And it happened to all of us before that we like committed and pushed files that we don't want, and then we blow up our GitHub repository and things get awkward because it gets pretty slow. And yeah, to avoid this, you can create a .gitignore file, the root of your repository. And in this file, you can specify all the file types Git should ignore and never commit. You could, for example, say all files that end with JPEG. Not sure if you want that, but things you definitely want are in I think I've closed my slides accidentally. Oh dear. So that. Things you definitely want are in this template I added to the slides. And it's actually the standard, like a pretty standard template. You can see here all the things like build artifacts or the project folder of, if you're using PyCharm, or your virtual env if that folder is part of your project. So it's a good thing to just copy everything here and add it to your gitignore file and save. And this file you then again can like add to your commit, say add gitignore, commit to be and push to your actual repository.
And it's totally fine if there's things in your gitignore that you're not even using, right? Like
Yeah,
just telling you what to ignore. So you can start with this file and then add to it as needed, as opposed to needing to figure out what of that file actually relates to what you're using.
Yeah, what I sometimes do is like I add project specific stuff. Like I know I have a checkpoints folder or whatever, which there are large files I don't want to track. So just add it on top. But these are like standard files you basically never want, like slash things. All right. So far so good with Git. Need to hurry up a bit.
Yeah, I think this will work a little bit into the work time, but I think the kind of important thing is the next bit where we're kind of going to go through a bit of the stuff about specifically SSHing into our set of remote machines. So yeah, exactly. And then we'll basically take all of this, we're gonna break up into our breakout rooms, and we'll try to actually make sure with each of you, with your instructors and TAs, you know, check in, can you SSH in? Do you have all this set up? And we'll just try to work everyone through the process and make sure everyone gets on the same page. But you know, and if you're already doing super great with all of this, like good for you, you can help your friends.
All right, we have created a Google Sheet, which you can open. It's linked in the slides, where we have created like a user for each one of you on one of the 4 machines we have. So you can look up your username here and the IP address of the machine you are assigned to, and also the initial password that is set. You can feel free to change it up later if you want. So the first thing we want to do is, before we created a local SSH key, and now we wanna push that SSH key to that machine. Like it's the same thing we did with GitHub where we copied it manually, but here we do it via command line just because it's faster. So let me do that as an example, very quick. So yeah. So the command is ssh id copy. No, copy ID. And then you look up your username. I created one for myself for this demo, which is Manuel at, and I created one at this address. And this should work out. It asked me to enter my password. You can take the one from the list. And now your key is added to the machine. And next time you try to interact with the machine, you shouldn't need your password. So yeah. One other thing you want to do for your own convenience is to set up an alias for the IP address. This makes it just way easier to connect. So what we're going to do is we change into the .ssh folder, and we create a file which is called config. And we edit that file. Then we basically copy this part from the presentation.
Sorry, can I just check, you're using Nano, right, but someone else might use?
Yes, I used Nano too.
Yeah, that's okay. It's just because there was Vim, I think, in Jupyter, one of them said Nano as well, so it doesn't matter which one, right?
Not
It
at
should
all.
be.
They're just text editors, so yeah, whatever you like. Some people, like I always use Vim because I just started using Vim 10 years ago when I started learning computer science, and I just have never switched. But yeah,
I think I'll stick with Vim.
Yeah.
Okay, so you want to set up your config file here. You can all find it in the presentation if it's too fast. But what I'm doing is I'm basically coming up with any name up here, which I call cb4e-2. I'm adding the IP address. I'm adding my user, and I'm referencing to the file we created before. And by saving this, I should be able to SSH into the machine just by saying SSH cb4e. I need to remember what I called it. I think -2. And that worked. So it's just a shortcut. No password, no user, and it just makes life easier for you. So I'm at one of the machines. One of the first things when you're there is you can check out NVIDIA -SMI to see, wow, there are 8 GPUs. That's something every machine learning PhD can only dream of. So you're very lucky.
Well, you each get one by default, but yes, it is, even one A40 is pretty nice.
That's nice. All right. What else do we have?
So I think once we break up into the breakout rooms, the big priorities are going to be making sure that everyone can SSH, that they set all this stuff up, that they're doing okay with VSCode or their own workflow if they have something that they want to do. So, and then once kind of that's all good to go, so if you're already super good to go on this, I think the next thing is figuring out how to copy your data onto that machine. And getting started on that process and getting that going, particularly if you have a lot of large data, that can take a bit of time. And you might want to discuss with your TAs about, and your instructor about basically what's the best way to, where your data is now and what's the best way to get it here. So for example, if you have your data just on a physical hard drive with you, it might be better to try to figure out a way to connect it directly via an Ethernet cable here at Caltech versus like trying to do it with Wi-Fi. So we can kind of work around like what are some of the options. If it's on a cloud thing already, you might want to use the command line copy from AWS or GS Util, whatever the different cloud provider is. Yeah, this is going to be a bit choose your own adventure because all of your data is somewhere weird. So it's going to be something that we can figure out the best way to get it here. But starting that so that the copy happens, it's going overnight. We want to run it in the background so that it doesn't get canceled if the terminal closes, and so that hopefully tomorrow everyone kind of has their data on the machine. That would be.
Yeah. So let me show you 2 or 3 more things. One which is okay. You want to get your project, your source code to the remote machine. You can easily do that with GitHub, which is a very reasonable workflow. For that, we open GitHub, go to our repository we just created, and then we click the yellow button, green button up here, which says code. And here it's important that you choose the SSH tab, which and copy that like repository address. And now we go back to our remote machine, and we just say git clone and paste that address. Type yes for the first time, and it doesn't work because I haven't added the SSH key for the remote machine. So we need to do the same procedure as we did before with our local machine, which is SSH keygen, create the file, open the file, tsr rsa pub, copy that one, and paste it to our GitHub user.
Would you then be adding 2 SSH keys? Because there's not a limit, right? You just keep adding them with the right name.
Say again?
You can add more than 1 key, right?
Yes,
So
you can add.
Because we did the local one before, and
Yes.
this is the one for our
Yes.
specific machine outside of the WSL that you downloaded to your own local machine.
So first key was to authenticate like our local machine, and now we create a separate one for the remote machine.
Yeah.
In principle, you could, with the very bad practice, you could like copy your private key from your local machine to the remote. Shouldn't do that because when you kind of lose, there might be a scenario where you want to remove that key because you're not using that machine anymore. So you want to be safe.
You wouldn't want to remove your whole one for your local machine.
Yeah, exactly.
Yeah.
So we add a second key here for the remote machine.
Sure.
Now we can go back and try the git clone again. Now it worked. If we say list directory, we will see awesome example is here. Navigate into it, and this is also a Git project now.
You paste it several times? Just paste it once.
Similarly, so what we did in the beginning with conda, you might also want to do on the remote machine because you need some kind of interpreter, which I'm not going to do now because it's very repetitive. One thing I want to show you is if you want to use VSCode for remote development, you can use the extension we installed before. You go to
Nothing on the side as well, under the add-ons and the icon.
I go this route because I don't see it, but thanks. So if I type remote, there is a thing like remote SSH connect to host. You can use that, which is also in the video, by the way. And since we have created our shortcut before, we can simply edit, select it here. Now a new VSCode window opens, which gives us the exact same interface, but except of working locally, we have it remotely. So we can open the Explorer here, we can create new folders, we can also just open the repository we just checked out, or we just cloned. And also the Git integration should work here. So yeah, we trust the authors. If we go to Git here, we see, we can use it the exact same way we did it before, but yeah, everything is remotely, so we wouldn't need any files locally. It's a matter of preference and a matter of choice, how you want to set it up.
One point maybe is that if you're working on the VSCode in remote mode, everything you're writing is on the remote machine, not on your local machine. Which means that if you don't push it to GitHub and later the code ends and like you don't have access to the remote machine anymore, you won't have access to your code. So make sure to work consistently with GitHub.
But this is just really good practice in general, and one of the things that makes GitHub kind of so magical is like if my computer crashes today, if I pour coffee all over my laptop, I don't lose anything. Like everything I have is somehow backed up, including all of my work and all of my code on GitHub. And then all I have to do is get a new laptop. It might suck, but then I can just get pull and have all of my code there. Or if I, end up now moving to my local cluster at my institution, when I go back to wherever I'm going back to, I can just get pull and have all of the code right there again. So it's, but yes, it is a good point that like, one of the things that's really useful about GitHub is that it gives you this ability to use the same code on lots of different machines.
Yeah, so coming to the last part, which might be very important for all of you, is actually moving, now that we have our code, we also want to move our data to the remote machine. There are two common protocols, one is SCP and one is rsync. They act kind of similar, but if you have to move larger files, I would definitely recommend to use rsync, just because it can resume uploads or downloads if your internet crashes, for example. So if you're trying to upload 200 gigabytes of images, better use rsync, because if it crashes halfway through with SCP, you need to start all over. The syntax is pretty simple. Should also be pre-installed in your command line. You call rsync minus abc, specify your local folder, and here instead of username at remote IP, we can just use the shortcut we had before. And it also works the other way around if you want to download from the remote